Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. Today we look at compound events. So compound event is one where there is more than one favourable outcome. When an event happens, we're interested in more than one thing at a time. So for example, let's go back to the classic example of I roll a normal six-sided die. Okay, so we know that the probability I roll a 3 is just 1 over 6, okay? That's not a compound event, it's a singular event. We're only interested in one thing, that a 3 happens. But today we'll be interested in things like if I roll a die, what's the probability I get a 5 or a 6? Okay, so now I'm interested in There's two favourable outcomes that I'm interested in. I could get 5 or a 6. So obviously the probability of that, there are two ways I could get that. I could get a 5 on the die, or I could get a 6 on the die. It'll be 2 out of 6, or 1/3 as it's simplified. They're the kind of things we're going to be looking at today. So we need to get some terminology right first. So it's a bit ambiguous, but I'm telling you that what we're going to do in maths, when I say or, I mean one or the other or both, okay? So, for example, if I am interested in, let's say, the probability that I select a student at random from the class and they play footy or soccer, what I actually mean is they play footy or soccer or both. They can do both, okay? That's what I mean when I say or. So the proper name for this is inclusive or. So when I say or, I mean inclusive or, I mean one or the other or both. It didn't matter in a question like this, the probability of 5 or 6, because both cannot happen. You cannot have a 5 and a 6 at the same time. You cannot have both of them. In that case, we say events are mutually exclusive. So if I roll a die, the event that I roll a 5 and the event that I roll a 6, they are mutually exclusive because they cannot both happen. Okay? But all other times when I say or in probability, I mean either event or both of them. Okay, so now we're going to have a look at some more compound events. So let's say I pick a random integer. Of course, remember integers just means whole number. And I'm going to say between and including 1 and 20. So sorry about my messy writing. This is between and including 1 and 20. So we're going to look at a few probabilities here. So what is the probability that I pick a 4 or I pick, say, a prime number? Okay? So these two events, they're different events, picking a prime number and picking a 4, okay? These two events are mutually exclusive. I can't pick a 4 and a prime number because I'm only picking one. I pick a random integer. So they're mutually exclusive. So if I want to figure out the probability that this happens, that I get 4 a prime number, I again have to use the formula, the number of favourable outcomes divided by the total number of possibilities. So if I pick a random integer, random whole number between including 1 and 20, there are 20 possible outcomes. So finding the number that goes on the bottom is easy. So now I've got to think about numbers that satisfy this 4 or a prime number. So how many ways can this occur? Well, I can pick a 4. If I pick a 4, then this will be true. I will have picked a 4 or a prime number. I could pick 2. Remember, 1 is not a prime number. 3 is a prime number, so is 5, 7, 11, 13, 17, and 19. So if I add all of these up, there are 9 possibilities. So the probability I pick a 4 or a prime number is 9 out of 20. So let's now look at the probability that I pick a number that's either even or a prime number. Now again, there are 2 kind of events that I'm interested in. So I could get an even number or a prime number. This time they're not mutually exclusive, because I can pick a number that is even and a prime number. They can both happen at the same time. So the possibilities here, so the even numbers, I could pick 2, 4, 6, 8, 10, 12, 14, 16, 18, or 20. So they're possibilities for picking an even number. And if I want to pick a prime number, again, I can pick 2, 3, 5, 7, 11, 13, 17, or 19, okay? Now, what, of course, you'll see is that 2 appears in both lists. I don't want to count it twice. It can't happen twice. I only count it once. So I'm going to get rid of one of those 2's. So these are all the possible outcomes. And if you count them up, you'll see that there are 17 possibilities. So the probability that I pick an even number or prime number is 17 over 20, or 0.85. But it's important when the two events are not mutually exclusive, it's important you don't double count an event which satisfies both. I don't want to double count situation where I pick an even number and a prime number. I only want to count that possibility once, okay? So that's the probability I pick an even or a prime number. You might get a question that says, what's the probability I pick an even or prime, but not both? So in this case, I want to pick a number that's even, a number that's prime, but I do not want to pick one that is both even and prime. So this time I don't want to include 2 at all. So I need to get rid of those possibilities. And that would leave me with 16 favourable outcomes out of 20, which is 0.8 or 4 over 5. Okay? Some other terminology we have to go to. So what would be, if I pick a random integer between including 1 and 20, what would be the probability I pick a number that is at least 5? So at least does include 5. So in this case, I need to include 5. So I want to pick a number that is 5 or more. It's either 5, 6, 7, 8, all the way up to 20. So if you're not sure off the top of your head what this is, it might be easier for you to use complements. So if I don't pick a number that is at least 5, I will pick either 1, 2, 3, or 4. So there's 4 ways that this event can't happen, so there must be 16 out of 20 ways it can happen, which is again 4 over 5, okay? The probability I pick a number no more than 7, for example. So this time, no more than 7 again includes 7. 7 is no more than 7. So the possibilities are 1, 2, 3, 4, 5, 6, or 7. 7 possibilities out of 20. So 7 out of 20 or 0.35. So the maths here is not very hard at all. You're just going to be putting one number on top of a fraction, one number on the bottom of a fraction. It's just getting the terminology right. Okay, the last thing I need to make sure we're clear on is the difference between and or. So look back at our example when I found the probability that I pick a number that's even or prime. So that means it could be even, could be prime, could be both. When I say and, it has to be both. So if I say the probability that a number is even and it's prime, I only include the events that satisfy both. In this case, I only include the numbers that are even and prime. I don't include numbers that are one or the other. So, of course, if I find the probability that it's even and prime, there's only one of those, which is 2. 2 is the only possibility out of 20. So the probability is 1 over 20. So or includes where only one of the things is satisfied, whereas and both must be satisfied. So just to give you a bit more of an example on this, if I talked about students in year 8 and students in my class, so if I said I want to talk to all students who are either in year 8 or in my class, that would include all the students in year 8. It would also include all the students in year 8, year 9, year 11 who are in my class. If I say I just want to talk to the students who are in year 8 and in my class, that's a much smaller number. It would only be the people in my 2 Year 8 classes. So all the other Year 8s who are not in my class would not be included in that. So, and when we're talking and, there's a much smaller number of possibilities. All right, again, if I haven't made anything clear, please let me know. Hope you've got something out of this video. This has been the luckiest maths teacher in the world. Have a great day.